Okay, I'll call this meeting of the Water Quality Management Committee to order. We are a reduced group today on such a beautiful day before Memorial Day. So Eric and Matt and John are elsewhere, and Sia is watching us from home and taking minutes. We have a speaker today, and it's Dr. Amy Costa. She's from the Center of Coastal Studies in Provincetown, and she's been working on contaminants of emerging concern. And these are of interest to us because we have the aquaculture project going on in Little Pond, and Amy has done some of her sampling in Little Pond. So Amy, I'm going to turn it over to you if you'd come up to the podium so everyone can hear you.
So I know you're probably all really familiar with contaminants of emerging concern, so I'm just going to briefly give you a background of what they are and how our work has started with this. What a contaminant of emerging concern is any anthropogenic chemical that's introduced into the environment, may pose a risk, and at present is unregulated. So it encompasses thousands of different chemicals. We concentrated for our work on hydrophilic compounds. So we only concentrated on a very small part of the many thousands that are out there. And so that's what I'm going to present today.
And hydrophilic means?
Hydrophilic means water-loving.
Water-loving.
So the more water-soluble versus hydrophobic, which is the more lipid-soluble.
Okay.
So the foundation for this work is our work on water quality. We currently have around 150 stations that we monitor for water quality. Several of these we've been doing for close to a decade now. More, we've added more as the years go by. But these are the stations that we're currently monitoring for the basic water quality parameters. And this, again, although a lot of people find water quality not as enticing as other things like contaminants of emerging concern, it is the foundation and the basis for everything else. So this slide just shows the different areas that we have since tested for contaminants of emerging concern, both in Cape Cod Bay and on the Nantucket Sound side. We started doing this, this type of pollutants was really brought into the forefront of research when USGS published their study in 2002 that looked at over 139 streams all across the United States. And they found in over 80%, I believe, 80% of the streams had at least one contaminant of emerging concern. Mm-hmm. So it was this work, 14 years ago that said they're out there. We need to start thinking about them. And then since then, of course, the work done by Silent Spring on Cape Cod has really brought it home. Their work on ponds found contaminants of emerging concern in our ponds. On Cape Cod, in public wells, they found, I think, 75% of public wells tested had at least one contaminant of emerging concern, and about 85% of the private wells that were tested, they found at least one contaminant. So we started our work. We assume that since it's found in the ponds, it's found in the groundwater, it's found in wells, it's found in rivers, we would also assume that it's making its way to the coast. So that's why we started looking for these contaminants in coastal waters. We started in 2010, and in 2010 we just did really preliminary work to see if we could detect them. Because often detecting pollutants in saline environments is somewhat more difficult than freshwater. But this work did show that yes, we can detect them. But I want to emphasize that what we detect are extremely low levels. So for example, we're measuring in parts per trillion, or nanograms per liter. So one example of this would be, one of the more prevalent ones is carbamazepine, and the average concentration from our samples is about 7 nanograms per liter. A dose of this drug for an adult is 400 milligrams per day. So in order to get this dosage, you would have to drink 57 million liters of water, which is equivalent to 23 Olympic-sized swimming pools. So it's very extremely low concentrations, and the only reason we can detect these concentrations is that we now have the technology to do so, whereas years ago we didn't.
And what does
carbamazepine
come from?
It's an anti-seizure, antidepressant drug.
Oh, really?
And it's one of the more persistent. Oh. Environmental persistence has to do with if it's resistant to microbial degradation or if it's resistant to absorption of the particles. So our first look at things concentrated on the more environmental persistent drugs, because if we're going to find anything, it's going to be one of the 4 or 5 that we originally tested for. And in 2012, once we found out we could detect them, we got funding from the Massachusetts Bay Program as well as the Massachusetts Environmental Trust to start to look at in more detail at what we're finding, different spatial and temporal trends. And we did find in both Cape Cod Bay and Nantucket Sound a pretty good relationship between dissolved inorganic nitrogen and contaminants of emerging concern. And this also has been found in other work, including that by Silent Spring. So this just shows, I know I'm going to concentrate on Little Pond, but I also want to put Little Pond in the context of the other stations we sampled, because a lot of times the numbers don't mean anything unless you compare them to other areas. So as I mentioned, we tested for 5 drugs initially to figure out, and 5 which were considered to be the more environmental persistent. We did this because it's cheaper to test for a few instead of many. And we did a broad suite. We did, I think, 20 stations or 20 different sites that we tested for these 5 drugs. I only found 4 of the contaminants because I later found out that one that was environmentally persistent is, it photodegrades pretty quickly. So all of our samples were taken from surface water. So it was trimethoprim and it degraded pretty quickly. So this just shows you where Little Pond is. We tested 2 sites in Little Pond, one towards the mouth, lower, and one more up in Little Pond. And this just shows you where their concentrations found in Little Pond compared to the rest of the stations that we measured in Nantucket Sound.
So in this is nanograms per liter, is that the scale?
Nanograms per liter,
Okay.
Yeah. And would you just describe the 4 compounds that you analyzed for that you found?
So sulfamethoxazole is an antibiotic. I think it's mostly used for like urinary tract infections, things like that. Cotinine is a derivative or a metabolite of nicotine. So it's nicotine passes through the body. That's one of those metabolites. And then carbamazepine is a antidepressant, anti-seizure drug, and acetaminophen is
like aspirin.
yeah.
What and where is Stewart Lower, and what are they doing wrong?
Stewart's Creek, I know. Stewart's Creek is in, it's in Hyannis. It was recently opened. The Army Corps, they recently really expanded and widened the culvert, so now there's a lot more flushing than it used to be. I don't know why it's so extremely high. We did anticipate it being higher than the other ones, but we also anticipate that if we go back, it will be lower since it is flushing so much better now.
Right.
But I think the wastewater treatment plant, about 50% of the effluent makes its way through the groundwater to that area.
Okay,
So that
it's a
could be-
wastewater treatment plant.
And then a
Could be-
lot of homes around
Yes,
it.
very, very dense.
Very dense population,
Yeah,
yeah.
okay.
So concentrating on Little Pond and the other sites in Falmouth that I believe you are considering or are interested in. Little Pond Upper and Lower, and then we have West Falmouth Harbor and Great Pond. We tested these sites both in July and October to look at seasonal variation, and as you would expect, typical higher concentrations during the summer months, a little bit lower in October. But Little Pond, again, does stick out compared to these other 2 with both higher concentrations of contaminants as well as a greater number than the other 2 sites.
Where in the pond is upper? Are you way at the head
No, it's upper is pretty close to the shellfish.
to where the shellfish demonstration
Right.
is?
Yep.
Okay.
Yep.
And lower is located
Near the mouth.
near the map. Okay.
So there's more flushing down there, but.
Right,
it's
so,
interesting, so-
yeah, it's interesting that in July it was higher, a little bit higher than the upper one. But again, this is one sample, one point in time, and that's
Yes.
one of the drawbacks with water samples, which I'll talk about a little bit later, is that a water sample is 1 liter of water taken from one point in one instant in time. So it only gives you a very, very narrow picture of what's going on.
Right.
So based on what we found, as well as our other water quality data, we wanted to look a little bit more in depth at some of the sites. We couldn't obviously test at all of the sites, so we narrowed the original 20-25 down to 10, and we looked for a wider suite of contaminants, and this just gives you the list of the different contaminants that we tested for. There were 9 hormones and 64 pharmaceuticals or personal care products. And these are the different sites. Again, Little Pond is right here. And you can see how it compares again to the other 9 sites that we tested for. So we found, we found 5 of the 9 hormones, and we found 11 of the 64 personal care products at all of our sites. Hormones were higher in Little Pond than they were at some of the other sites. We also found a wider variety of contaminants at Little Pond than we did at some of the other sites, although they weren't, Stewart's Creek was still higher in concentration.
Okay, these are still, I mean, even though they look tall on this chart relative to the dose
Tiny amount.
It's a tiny amount. Yeah.
Tiny amount, like, yeah, again, parts per trillion, when you're dosing in milligrams, which is, parts per thousand.
I'm sorry, could you go back just a minute? So PCPs is personal care products. What's
Pharmaceutical,
Pharmaceutical.
pharmaceutical active
okay.
contaminants or something.
Oh, I see.
So sometimes, you see a lot of different acronyms. Some group as PCPs, which is pharmaceuticals, personal care products. I just kept it separate.
Okay.
And I also should mention that we got the help of many, many, many different institutions to help, including the town of Falmouth, Webner, Faces, they all pitched in and helped with this. So as I said, we were looking at just water, so one discrete sample, one incident at a time, and we realized that this is somewhat limited. So we expanded our work in 2014 with funding from the Massachusetts Environmental Trust, to look at these contaminants but use passive samplers. So to get a time integrated value, so to get an idea, these were left out for 40 days. So we got an idea of the contamination within each site over a 40-day period, which is a lot, it gives you a lot more information. And we also put out oysters along with these samplers. This, we hope, would give us information on possible bioaccumulation, because our hypothesis going into this was that the passive samplers would accumulate everything that was in there. And we would then compare that to the oyster tissue to see what the oysters were and were not accumulating within their tissues. So oysters are an obvious choice because they do filter so much water, 50 gallons per day, I believe is the number that's thrown around. And they can survive in a variety of environments, from very, very polluted environments to pristine environments. So they were an obvious choice for bioaccumulation. The POSIS sampler, which you're probably not as familiar with, it stands for Polar Organic Chemical Integrative Sampler. And this one, it was developed by USGS and is marketed by EST Laboratories. And this type of sampler is designed to collect the water-soluble, the hydrophilic compounds, like the ones that we've already tested the water for, the prescription drugs and pharmaceuticals, personal care products. And like I said, it provides a time-weighted average concentration over extended periods of time. You can leave it out as long as you want to. We were somewhat limited to our 40-day period because of biofouling. We had a lot of growth in some of these areas, so we had to remove it.
Does it involve a pump, or is it just diffusion?
It just needs to be submerged in water, and water just needs to flow through it. So no pump. So those are just membranes. So it's a metal disc, and then it's a membrane in there, and the water just flows.
It's amazing.
And they do have one that for the hydrophobic compounds also. So again, we had to narrow our sites down once again because, again, costs are prohibitive for this type of analysis. We kept 4 sites on Nantucket, on the Cape, and one on Martha's Vineyard, and one in Nantucket. Little Pond, again, we kept in there. So we deployed 70 oyster seed that were about 1.5 inches. We got the oyster seed from one source, so all the, so it would be equivalent across the sites. So we got oyster seed, and we attached to that a canister. And within the canister, there's 6 different POSIS membranes. We had to use so many membranes because we expected the concentrations to be low, and the more membranes, the more surface area to collect them. And then we deploy them. 40 days later, we retrieve them. We did, in addition to contaminants of emergent concern, we also did the basic analysis of oyster tissue and oysters, including shell weight, or shell height, weight, and then approximate analysis. This just is, just so you can see how Little Pond, again, compares to the other sites. Little Pond, the oysters grew a lot.
Yes.
It was that one and what we call John's Dock, which is in the 3-bay system. Those
Right.
2 were our top growers.
Right.
And even in that picture, you can see how different the oysters were. They were all in the water for 40 days, but just the environment had a lot of affected the color of the shell, the size of the shell, the growth. It was a lot more variation than I expected, I guess.
Are there any more nutrient analysis being done that in any of those harbors that you could look at
We did. We collected
We collected
water
that too?
quality data
Okay.
from all these.
Yeah.
Yes. And then for the contaminants emerging concern, just the analytical stuff behind it. It was done with the methanol extraction for the 73 different contaminants, and then the extract was analyzed with the liquid chromatography, electrospray, ionization, tandem mass spectrometry. And these are the results. I should emphasize that these results are very preliminary. I'm working with an environmental toxicologist to make more sense of these. So I've just given you the raw data. And his word of caution is that some of these were at or just above the method detection limit, so you might not necessarily need to consider them. So again, I'm working with him on that. And when these results are eventually published, they'll be probably a little bit different than what you're seeing now. But these are the raw numbers that came from the lab.
Can we look at them for a minute?
Yes.
So taking Little Pond, you've got the USGS filter
Right.
doing its job, and then you've got the oysters, which were right next to it, doing their job.
Right.
And so it looks like the filter actually gathered more.
Well, no, because the oysters is per gram. So what should we assume for the gram weight of the oyster
Yes.
tissue?
Is that
100
So-
grams? What does an oyster weigh after you take the
An
shell away?
edible oyster weighs 15 grams.
Weighs
So you
15?
multiply those and you come out about the same.
Yeah, I see what that's good.
Assuming that the cross-section of an oyster is about the same as the filter. But then, on the other hand, the oyster is pumping much more water
Through it.
than the filter probably gets by just sitting there. So it's complicated.
It's complicated.
Uh,
But a word of caution, this is hormones, and all these hormones are naturally occurring in the oysters.
Naturally occurring in the oysters.
Oh.
Right.
That would complicate
Yes.
things.
So
It's a good thing they're there. That's all. If they weren't there, we'd have a
Right.
problem.
So I'm not putting any effort into making sense of this.
Okay.
For the
Okay.
oyster
All right.
tissue. For the process, it's interesting. The process is different, but for the oyster tissue, I wouldn't worry about
Right.
hormones in the oyster tissue. because
Okay,
they're natural.
okay.
It
That's
would
good.
be interesting, and somebody brought this up in another presentation, to compare, since we know they're there, but we don't know necessarily concentrations, it would be interesting to compare sites for the different concentrations and then relate that back to water quality. And then maybe you could, glean something from the hormone data. But just as it is, I wouldn't be able to say much. But the pharmaceuticals and personal care products are not naturally occurring. And the only source of these is humans. So you can put a little bit more effort into making this make sense. These, again, Little Pond has, the post has found higher concentrations in Little Pond than the other sites. By this time, this was a year after the water samples were collected. So Stewart's Creek by that time had flushed out a little bit more. So I think that's why we saw an improvement in Stewart's Creek relative to Little Pond. One thing that jumps out is that the POSIS does collect a lot more types of contaminants than were found in the oyster tissue.
So it's a more effective sampler if one wants to know the range of chemicals that are in the water.
Right.
But if our concern is what's affecting the oysters, then we'd just be looking at the data on the right-hand side.
Right.
And these again are low, right, relative to the
Very low.
dose? I mean, they're,
Extremely low.
Extremely
And I'll
low,
show
yeah.
a slide in a minute that just shows you just how low it is. But this just compares the water to the POSIS to the oysters for both the hormones. Hormones are on the top, and then personal care products and pharmaceuticals are on the bottom. And this table just lists them, and with an X marking which one was found where. So again, this shows how more representative the POSIS is compared to either water or oysters. Again, because the water is one instant in time, and the oysters do have some biological, filters going on, I guess.
So let's look at the oysters, the ones that, the chemicals that in particular were found there, not the hormones, but the personal care products. What's that purple one?
So we have caffeine,
Caffeine.
we have
Okay, we can,
cotinine,
wide awake oysters.
the metabolite of nicotine. We have this one is DEET.
DEET.
Yeah.
And that's what's used like for mosquito spray, right?
Yeah.
No kidding.
And we have, what do we have? Nicotine,
Yeah.
I can't pronounce that. It's a derivative, paraxathine is a derivative, I believe, of caffeine, or a metabolite of caffeine.
So DEET and caffeine, you
Right.
could easily imagine a mechanism whereby both of those could be directly introduced into the water.
Yeah, but not
Well,
likely. How many people pour
Do
their
people-
coffee into the water?
Well,
it goes through the septic.
but
there's
it's
a
not
breakdown.
processed.
Well, again, caffeine is also one that is, it's so prevalent that EPA used to look at it as an indicator of wastewater, but they've since kind of cautioned against using it because it is so prevalent, and these are such low concentrations. Peter Philbrook at EPA told me that if I have a cup of coffee 3 hours before I collect a sample and breathe on the sample, I've contaminated it. If somebody working in their lab has had coffee and then processes the sample, just the amount of caffeine in your breath is going to contaminate the samples. So caffeine, I don't know. I think you would need a lot higher concentrations than we found to say that it's a big contributor. It's because these levels are so low, it's really hard to say too much,
Yeah.
to get too
There
up in
are
arms
no
about
meaningful threshold. Somebody should be working on meaningful threshold.
Right. And I think that's down the road, and I know some, EPA is looking at that to some extent, but this is still, I guess, relatively new.
Okay, now DEET, that's obviously an abbreviation for some chemical. Is there any toxicological information that might indicate that that was a problem?
I'm not sure.
You don't know?
Yeah, I'm not
Okay.
an environmental chemist, so I don't.
Okay.
I'm very limited in what I know about these.
Okay.
But DEET is what's in bug spray. That is,
Yes, right.
It's what you
very
don't want to put on your skin anymore
Yeah.
because I think they've even decreased the amount of DEET in
Yeah.
a lot of bug sprays because.
But you could compare, as you did in your nice initial slide with the swimming pools
Yeah, right.
and antidepressant or whatever it was. You could
And
compare
yeah.
this
And I will.
to what you used to get when you put DEET on to keep off the mosquito.
Right. So this slide, you keep mentioning how much. So this slide kind of gives you an indication of how much of these different chemicals are in an oyster. So a 15-gram oyster would have this amount of nanograms of each of the contaminants that we found. So if you relate that to, say, the amount of caffeine that we found in these oysters, relate that to an 8-ounce cup of coffee, you'd have to eat 870,000 oysters to get the amount of caffeine in 1 cup of coffee. Or you'd have to drink, or you'd have to eat 110,000 oysters to get the amount of nicotine in a cigarette, or 150,000 oysters to get the amount of theobromine in a bar of chocolate.
Okay.
So this isn't,
Not gonna
don't
happen.
walk away from this meeting and say, I'm never going to eat an oyster again, because that's not where you're. And I should also emphasize that all the sites we tested, including Little Pond, Stewart's Creek, oysters aren't harvested. So we found, we concentrate on the more polluted sites.
Right,
So,
right.
that in itself, we should have, our site that was kind of a control was the one in Nantucket Harbor because it was around open shellfish beds. And that setup actually washed up on shore. So the data that we got was not usable.
Oh, it's too bad.
Yeah, so. This just, again, it gives the list and the different uses for the different contaminants. There are only 3 that are shown in gray that were not found in Little Pond, but that were found at some of the other sites. And then, if you're interested, see, I don't know what your interest is. If your interest is looking at contamination in oyster tissue, you might do better to look at the more hydrophobic compounds, because the hydrophobic compounds are lipid soluble. So the oysters would be more likely to bioaccumulate lipid soluble types of contaminants. The fact that we found hydrophilic compounds in oyster tissue was surprising. I assumed that since they had, they're water soluble, I assumed they would just be filtered out. And there have been studies that have also seen some accumulation of these types of compounds, but the accumulation is only for a very short period of time. So for some of the PCBs or PAHs, it would take oysters months to purge themselves of these chemicals, whereas with the hydrophilic compounds, they're gone within days. So that's something to keep in mind.
But the hydrophilic compounds that you, in the sampler versus the oyster, was higher in the sampler anyway, so in a way, they may be ahead of the game because they're moving so much water, right?
Right.
So their discharge, there's not as much in them as there is just in the water itself.
Could be, right? Yeah.
Although, drink too much estuary water, right? So.
And there is a sampler, it's called SPMD, that will target the more hydrophobic compounds.
That wasn't part of your study?
It wasn't part, because our we were more interested in the hydrophilic compounds. Sometimes they're somewhat more indicative of wastewater because they are the water soluble, and they
Have any other groups studied the hydrophobic in oysters?
Silent Spring does include PCBs and several of the other hydrophobic in their work, and I think they're trying to figure out how, because they've detected it in wells, and I think they're trying to figure out how it gets into the wells, because it may or may not be through our septic systems. Because some of these drugs, like flame retardants, how would that get into a septic system? So they're trying to figure out why some of these that you wouldn't expect to be
From washing your clothes?
could be, but some, a lot of that, or not a lot, but some of that water is diverted in gray water versus black water. But I don't know. So they're up on this type of work. And I think that's it. These are just need to mention all the different partners, collaborators, and funders that have been involved in this project.
Where's Eurofins?
Eurofins is the laboratory that does the analysis.
Oh, okay.
They
I'm
were
not
originally,
familiar with it.
they were originally called UL, and Laurel was the one that turned me on to them. And then since then, I think it was just last year, Eurofins brought out UL.
So,
They're in Indiana, I believe.
so I think, clearly in our interest area for what we're doing with the nitrogen attenuation with the shellfish aquaculture demonstration, it would be interesting to get the other spectrum, the hydrophobic. So it would be interesting to look at a couple things. One would be Little Pond, which you've already started. Another could be one of the relay areas where they go, such as Green Pond or Quistit Harbor, and also West Falmouth Harbor, where they're also relayed, because we also have the wastewater treatment effluent coming through there, so it might be a way, plant effluent coming through there. So, it might be interesting to try and, because if this is relatively background, I don't know, maybe the same with hydrophobic, but as you say, there's a greater chance it may accumulate in the tissue than the hydrophilic would.
Right. But I don't know if there's a greater chance that we would detect them, because it's all based on the log KOW. So the lower the log KOW, the more hydrophilic.
I see.
The higher, the more hydrophobic. And then the different contaminants that have the higher KOWs are more likely to absorb to sediments. So as they pass through the ground, they might not be transported as far out into into
I see.
coastal waters as some of the hydrophilic compounds. So that's originally why
That's
we
what-
concentrated on
what-
hydrophilic.
hydrophilic.
But they are in the sediments. You know, there's probably more of the hydrophobic in the sediments. So if they leach out and the oysters are nearby, so it would be definitely interesting to include both of those.
Is there any information from other, not here in Cape Cod or in this area, but for the hydrophobic testing in shellfish, is there materials that could be referenced? that We
Yes.
could look at to see
Yes.
what the experience
California,
is?
with their Mussel Watch program, has
Uh-huh.
done a lot of work, and they deployed POSIS and both the hydrophilic and the hydrophobic samplers, and compared that to mussel tissue. And there was a really good relationship between the chemicals that were found in the hydrophobic samplers, good comparison with that was found in the mussel tissue. Hydrophilic and mussel tissue wasn't as good a comparison, probably because the mussels pass them through, metabolize them. And then that's another thing, are the contaminants brought into the tissue, or are they just passed through and deposited in the pseudofeces? Or are they just passed through? And then there's so many unknowns. Other studies have shown that in high concentrations of some of these contaminants, the mussel or the shellfish will actually stop feeding. So if it gets too high, they'll stop. So there's a lot going on.
From a dose perspective, has there been anything close to, anything less than 860,000 oysters or something that you would have to eat? But I'm just, that sounds like an average dinner. But anyway.
I don't
know.
think there's been any detection that's
Anything
been
like-
don't eat the oysters because they have high
I
concentrations
see.
of
Okay.
these.
Right. Yes, I think that's a very effective slide. You might go back to it just for a minute. You've been saying you're measuring these things in parts per trillion. And so I think it's really important for people to realize that finding their presence is one thing, but presence at a level that could in any way affect public health. And we do, as you pointed out, move all of the oysters that are in Little Pond. We don't harvest them for eating, we just harvest them for transport to other areas, and then they filter out quite quickly.
And the ones, like in that one slide that I compared Little Pond to West Falmouth Harbor and Great Pond,
Yes.
concentrations were so much higher in Little Pond. So this is
Yes.
the average concentrations for Little Pond. If you look at other sites, the concentrations might be lower, so you might have to eat a
Even
quarter,
more.
a million oysters. Right.
More than a million.
Right.
Okay, right.
Okay.
Very good. Well, initially people were saying, well, we shouldn't look at contaminants of emerging concern. And then Silent Spring kept bringing up the issue, and so we're actually, as a town, indebted to your agency for actually pursuing this and providing us with this information. It's better to know and to have a sense of proportion than to say, well, we don't know.
And I should also mention that, again, the hydrophilic compounds that we test for are probably passed through
Pass through.
fairly quickly if they
Right.
do accumulate. And so bioaccumulation is different from biomagnification.
Mm-hmm.
So the hydrophobic are more likely to make their way up the food chain, whereas these,
So,
when we eat these oysters, they're probably not even there anymore. So,
okay.
so somebody asked me after a presentation, you still eat oysters?
Do you study apex predators in fish? Swordfish, other good things like that?
We haven't. The Center for Coastal Studies does whale research, and there have been some studies that have not done specifically by the center, but I believe we've been involved in some, but that have shown PCBs in whale blubber, whale tissue.
Yes, I've heard
So
that.
some of the hydrophobic compounds do make their way up. I don't know of any studies that have looked at these types of compounds in the apex predators, but it would be interesting. But again, those move around, so that's why we concentrated on
of course,
sessile
of course.
organisms to be more representative of the water body.
Okay. Are you planning any follow-up work at this point? Is there any follow-up that's certain, or is there any follow-up that's just sort of in the we would like to stage?
There's none that is certain.
Okay.
We didn't go back to the Massachusetts Environmental Trust this year for this work.
Okay.
There's some that, there's a lot of work that I would like to do, more on, the purging, if they do clean themselves, how long it takes them to purge themselves. And relate our data back to watersheds and the different, what's going on within a watershed, and if that is correlated at all with the different contaminants that we're finding in the oysters and in the postas. So there's a lot of work that still needs to be done, but
Okay.
it's still on the drawing board.
Okay. And looking for funding.
And looking for funding. Oh, yeah, some of these, to do one sample of oyster tissue and postas membrane was about $3,000. So
3,000.
right, we got, I think our grant from MET was around 40,000, 35 of which went to analysis. So it was,
Oh my, that is huge.
and so that's what we were talking before, that
Yeah.
if we could narrow it down to specific compounds
Right.
to look for, rather than testing for 74, the majority of which we didn't even detect.
Right.
If we narrowed it down to just a couple, we could really reduce the cost of analysis.
So you could only look at 11 or 12 oysters?
No, 11 or 12 compounds.
Oh.
So for the oyster tissue, we had to homogenize, I forget how many grams they needed.
I'm sorry, I misunderstood you.
But yeah, so this wasn't one oyster. It was, for some of the sites, we had to use all 70 oysters to get enough tissue for them to analyze.
But we could possibly do one sample, like at the end of the season, when the greatest chance of the accumulation may be there, right? Because of the growth and everything and the.
Yes and no, because I don't think they accumulate for long periods of time.
Hydrophobic.
Hydrophobic, yes.
Yeah, for hydrophobic.
For
That's what I'm saying.
hydrophobic,
For
yes, I would
hydrophobic, it would be.
wait longer.
We could do, if we could get some money together, we might be able to do a sample, say, late September, October, early October, and just do one and see what we come up with.
Right.
And then work from that. I mean, it has to be in the water longer, but the sampling would be done
In the,
at that
yeah,
time.
later.
Okay.
Lynn, do you have any questions?
I guess you were saying that you have not done the hydrophobic yet, but you plan to do so, and you have some money to do so.
We do not have any money to do so. We would like to do so,
Yeah.
but we are pursuing different funding sources. Nothing definite.
Is there any difference as a general category between the importance of hydrophobic and the importance of hydrophilic in terms of the effects on people? In other words, is there any idea that hydrophilic compounds are more likely to provide problems than hydrophobic, or that hydrophobic are more likely to provide, or is anything like that?
The hydrophobic are more likely to bioaccumulate.
Yes.
So they would be
So
more
there's
likely
more
to,
of them, yes.
to stay in you once
Right.
they're in there.
So is it,
That, as far as, not taking accumulation into consideration, I don't know if you could say DEET is any worse than a PCB or not.
I mean, we take in all sorts of stuff in our bodies and we get rid of it, if it's hydrophilic.
Right.
If it's hydrophobic, it may accumulate in our bodies.
Right. But these are drugs, and they're designed to have an impact. So before we excrete them or metabolize them, they do have an impact.
Right.
So what that impact is still not known.
How does it, for example, let's take a particular one. In a human body, if you let's say acetaminophen or something like that, what is the concentration in your body that is put in there to affect you, and how does it compare with the concentration you'd get from, is it many tens of thousands of times as high? Or?
That's the swimming
Sure.
pool's fault.
You're right.
You have
Yeah.
to drink about how many swimming pools? About
Yeah, 23
20.
Olympic-sized swimming pools to get
23
the
You drink
dose.
23 swimming pools, and they will have
And you
taken
have-
in one
One
tablet,
dose.
one typical prescription tablet.
Is that right, or would you have to take 120,000 swimming pools to get?
No, well, she figured it out. I mean, it's just scaling.
23,
I think, I mean.
23 pools is enough. Doesn't have to be
No,
more.
But another
In other words,
thing,
you were saying
Per
that
day.
you were measuring.
Or
You
whatever.
did say, okay, I understand.
but another concern is that although these are extremely low, they could have synergistic effects.
Yes.
So it's the combination of a lot of different at very low levels.
Yeah.
It's something that we don't know anything about, because even tests that are done by EPA or whatever. Now they're starting to look at combinations, but they usually concentrate on one drug at a time and the different concentrations. But the whole variety at once is.
Well, has anyone done any studies on the Cape with backyard garden vegetables to see what's in them, just to get an idea? I don't know what it would be, but it would be interesting because some are organic and some are not. But it would be
Right, and
interesting
some
to
are-
know what. There might be some studies around on that. That would be also another relative, risk factor.
I think there was work that was done on food that was irrigated with wastewater.
Mm.
And it did show some of the types. I don't remember specifics, but some types did accumulate some of the contaminants that were not removed from the wastewater before. Because wastewater treatment plants don't remove these.
No.
And if
You wouldn't expect them to.
Yeah,
if you compost your kitchen waste, depending what you're eating, and then you apply that to your
But
garden.
as we agreed before, I think that establishing meaningful thresholds is sort of essential to understand this.
Yeah.
But that's a totally different field. That's epidemiology. That's not what you people do.
No.
You have to study thousands of people, not thousands of oysters. to
Right,
do
but these can be compared to those studies must be done by somebody else.
And this study wasn't designed to look at human impacts at all. We were interested in coastal ecosystems. So to relate it back to humans is way beyond anything that I could ever guess.
And nobody's doing it, almost by definition. That's why they're called contaminants of emerging concern.
right.
They're the ones that haven't been regulated yet.
Yeah.
And there are other epidemiological studies that people would rather do.
All right.
Great,
Amy, thank you
Thank
very
you.
much.
Thank
It was
you.
a pleasure.
great,
And
thank you.
we wish you that you get some funding so we can know about the hydrophobic ones.
I noticed that Falmouth
Yes.
is not on the list of supporters. Maybe we ought to recommend that Falmouth.
Oh, on her slide with.
Yes.
You have to give her money.
And Town of Falmouth was on there because we worked
Was
with.
it? Oh, I didn't see it.
Oh.
Okay.
We worked with Sia, and she helped us put out the
Oh,
oyster
okay.
villages.
I just didn't see it on there. That's
All right.
good to know that.
Well,
And Town of Falmouth was
Good.
definitely a participant in this project.
Okay, thank you very much. Have a nice weekend.
Yeah, thank you.
All right. We do have a short agenda here. So the next item was reports from members and staff having to do with any particular projects that you're working with. Ron?
Yeah, I have one. I was going
Okay.
I've got, it'd be easier for me just to put a couple slides up to show that.
Oh, okay,
That's okay.
sure.
Somebody had something else because it's going to take me a little while to figure this out.
Okay, do you have any reports? Lynn?
I have just a very, very short report. I attended, Matt couldn't go to the last meeting of the Mashpee Sewer Commission,
Ah,
and I went to that.
okay.
I'm trying to go to them, but he specifically asked me to go to that.
Okay,
I think there's two things that might be worthwhile mentioning. After the meeting, I talked with Rick York,
Rick York, who's the shellfish warden.
Shellfish Warden. I asked him specifically, can you give me a rundown of the reasons why you say that oysters would not be something you could use in the Quashnet River? And he had previously said, it's not a good place to put them.
Okay,
And he began to give, and I think we ought to quiz him more about that, a very detailed discussion of why, the reasons he gave. The really big reason was that there's not enough area to make it worthwhile doing a whole lot of oysters there, but
Right.
he was not saying that oysters could not be used there. He was talking about things like the number of swans that were there. There's a whole lot of issues,
okay,
including the issue which we're looking at now is what would happen if you flush it out a little better. They also asked how we were coming along with that, and I said we were looking at funding possibilities, but we had not done anything specific about that yet.
that's right.
And secondly, they asked, we agreed that neither Falmouth nor Mashpee have yet named the people who are going to be discussing this, and that was something that both of us have to do. So that was really all that was said.
Okay, and are we expecting it's the selectmen who will name the people to this group?
I told them that I thought that we were that we were suggesting that the selectmen be the group that did it,
Okay.
and that it has to be done by the 15th of June or something.
Ah.
Something has to be done by the 15th of June. Somebody has to make a decision about who is going to be responsible for it, not necessarily appointing the committee by that time. But,
Okay, I
and
think.
so I told them we didn't know yet. We
Yeah,
couldn't answer
and
that.
you may have sort of merged two things together.
Yeah.
The 15th of June is a 2:08 deadline, and it's for the Department of Environmental Protection to file the plan with EPA, and that has input from the Cape Cod Commission, so.
I understand that that's.
So
the point.
unless this is a deadline for two different things.
I have understood all along that by the 15th of June, we have to have said who we're going to, how we're going to handle this, that's all. But we don't have to do anything by that time.
Okay.
Because I guess that's part of the filing, we have to say that.
I see, okay.
That's what I understand.
Then the answer to that is that there's been a series of workshops with the selectmen of the
All
4
right.
Upper Cape towns, and I've been attending that.
All right, okay.
And the one in June has not yet been scheduled, but I would, so at this point, it's sort of what we call the body of the whole.
Yeah,
All
right,
the
yeah,
selectmen
yeah.
come, or as many as are interested.
Yeah.
And there's been very good representation from all 4 towns at these meetings. So that everybody's involved, and so there've been no designees.
But I told them that we didn't know the designees yet.
Yeah,
And secondly, they said they couldn't do anything until after the election, and of course that's,
yes.
they
Right.
said they hadn't made any decisions because they had to have the election first.
And do you know what happened with the Mashpee election?
I don't know what happened with the Mashpee election.
Okay, it was on the ballot to decide whether the responsibility for wastewater projects within Mashpee would be handled by the selectmen, or whether it would be handled by the water district,
Yes.
which would become a water and sewer district.
Right.
And the measure failed to transfer the jurisdiction to the water district.
I
So
see.
the jurisdiction will be with the selectmen.
Okay.
So that's an important political decision
Right,
that
okay.
Mashpee has made.
I didn't look at that in the last, I was
Yeah,
busy doing other things, trying to figure out.
I've been waiting, because that has a lot to do with, how we shape our plans. We need to know who are we going to be working with. So the answer is, it'll be the selectmen. And there is one new selectman now as well. I've forgotten his name, but there has been some change on the board.
The other thing I had is, I talked, Sia mentioned several weeks ago, a couple of months ago, that there were 2 people, 2 young women, who were doing research on eco-toilets in connection with Falmouth, and
Yes.
would we cooperate with them?
Okay?
And then in the last few weeks, Matt and I both asked, we'd like to be in connection with that.
Okay.
And both of them have called me. I think they've also.
These young women.
Both of these young women have called me.
Okay?
One of them is a postdoc who is working with Silent Spring and some other people at a university. She's looking into the question of eco-toilets in Falmouth.
Okay?
And she's previously done work in Bolivia and in I think it's Colombia, and Belize on sewer waste. She's done work in wastewater. She's a PhD in environmental science.
Okay.
She's done work on wastewater in water and wastewater in those countries.
Okay.
And she's looking at our project to try to, I think her point is to try to discover what we have done, how it has worked, what its possibilities are for the future, and so forth, and to make a report on that.
Okay?
The second one is a graduate student, trying to remember exactly where she's from, but she's doing her dissertation on a comparison of the work being done at the at the Rich Earth Institute in Brattleboro, Vermont, on urine for fertilizer, and what we've been doing in Falmouth. She's looking at the two and seeing what's happening in both places and whether there's any way of concentrating.
Okay.
And I had my first interview with the first one of the young women, Marianne Cairns, 2 days ago.
Okay.
Excellent person,
Okay.
excellent questions, an excellent discussion. It was by phone for an hour. And next week I'm going to have a personal interview with the other woman.
Okay.
And I think
Good.
that they're interviewing all of the people in Falmouth who are concerned with this for the most part.
Okay.
And so I think it's going to be an excellent resource to have
Good.
those reports.
Okay. You ready, Ron?
Yeah, I'm ready. Yeah.
Okay.
Thank you.
All right.
Firstly, thanks. This is just a quick, very preliminary report, but this report is based on the report for the SMAS report from 2014 that was approved by this committee, or accepted by this committee, I would say, on March 19th, the past March 19th. And so in looking at that report, I wasn't here for that meeting, I was away, but I had the report and I did some analysis. And it asked that some of this analysis be done, if possible. I sent a note to Eric to see if, so then I went ahead, I just came back from, I was away, and I just started to do some analysis. But here's an image. This is as small as our little aquaculture demonstration project is. You can see it from space.
Wow.
Is that from space?
Oh yeah, you can see it from
Right.
Google Earth, and you can
Wow.
see, those are the bags, floating
Okay.
bags. Very neatly done, I must say.
Yes,
Yeah.
Google Earth.
And-
Absolutely.
But Ron,
Yeah.
you can also see the sofa on my deck.
I know. Okay. Anyway, okay, fair enough.
All right.
Fair
And
enough.
is the dock up there
I think that's Paul's dock. Yeah.
Narragansett, is that Narragansett Street from
Yeah,
which?
Narragansett Street, right at the end of Narragansett
From which we
Street,
launch
right.
these
Yeah,
things.
and that was the top of is a float. It was like the working space for Ryan last summer.
Very
And
good.
anyway, so this was it. And then what was interesting is that we have a 2-acre area that we've been allowed to work within
Right.
in this vicinity. Well, it turns out we only use 0.3 acres.
I know.
Because I measured
Okay.
well, according to this measurement, using the tool from that, it was
Really?
about 0.3 acres.
0.3 acres for those 6 rafts.
Yeah, it's about 100 feet long and 130 feet wide, or whatever. The 2 dimensions
Okay.
are roughly that.
So it matters how closely together they are.
Well, I just measured
No,
the
but I mean, I'm
outside.
just saying it's
Yes.
a pseudo-scientific number because there's the density of the oysters within that.
Yeah.
The rows could be closer together.
They could be closer, and they could be further apart. It's just that
Right.
we use the space here. And so in looking at this, I then looked at the report, and this is the cover of the report. And then went through it, and I think there are 2 things. Again, all this is very preliminary. There's very limited data. We need to really look much further in this, but at least there's some indication here of something. And what I found was, in going through the report, there are really 2 things that as our committee is concerned with, although we are concerned with the ecological integrity of Little Pond and everything like this, but from our standpoint, as a demonstration project, we're interested in nitrogen attenuation either into growth or through other mechanisms, which could be denitrification or microbial denitrification as another. So then in the report, this is taken from the report figure 6-3, and it's basically a probability assessment of where the fecal matter, how far it would spread from the rafts. And the rafts would essentially be on the left. Okay,
Yeah.
from 0 to the left, okay. And therefore, you can say this is sort of an estimate. So most of it is clearly coming in underneath or in the vicinity according to this probability assessment. But this, to some extent, may have some indication of where denitrification may also be going on, or the associated denitrification with the oysters. And then there's one table. Again, very limited data, like 1 data point, but there's one table that is in the report, that pertains to, particularly to denitrification and other concentrations. And it's just that far right column, and to nitrogen gas removal in milligrams per square meter per day. And at a distance of 0, which is right in the bag area, we have 165.5, which oddly enough is quite close to what they measured in the Chesapeake for oyster reefs, which was 165.6. So I think it's just happenstance. We happen to be that close. I mean, I don't even know if there's any relationship, but anyway, this is what they measured in this.
Okay.
And then moving out 54 meters from the bags, they measured a lower level of 68. And then at 103 meters, 0.
Nothing.
I don't know, well, 0 is very low anyway, but where that 0 really starts, it's just that they measured 104 meters away. If they measured 80 meters away, it might have been 0 also. But so the question is to get better understanding of the significance of these figures. And so then I did a little schematic of the idea, and we had this 0.3 acre area, and then we have within it the 165.5 milligrams per liter within that 0.3 acres. If we average it, it may not even be even through there, but if it were even, we'd end up with the way I calculated it was to divide that 165.5 by 2 to get kind of an average for because this is at the end of the season, like in late September, and the total nitrogen removal would have been about 10 kilograms from denitrification through that method for the culture area. And the oysters themselves, SIA did some measurements of 1-inch oysters and got 0.009 grams of nitrogen per oyster, and there were about 1.5 million. So we end up with about 13.5 kilograms of nitrogen that went into growth. Then, if you look at the inner influence area, which is the only area that I did calculations for in this rendition, I did some for the outer area, but I don't know really where it begins and ends. But the perimeter of that area is was measured, there's a measurement of 68 milligrams of nitrogen per square meter per day at the edge there. So it dropped off. And then I took that number and added it to the 165.5, and then divided that by 2 and got an average for the area around it, and then I divided that again by 2 because of the accumulation over time. In other words, we're kind of at the peak period, or maybe denitrification is not develops as the oysters grow and more fecal matter settles. As fecal matter settles, it could be bringing oxygen-rich upper water down with it to help nitrification first, and then it's covered, and then you get anoxic and denitrification, which is sort of the standard understanding of the process. So that came out to, that inner influence area came out to about 112.3 kilograms. So the total for nitrogen attenuation, if you added those up, if it's, it would be about 135.8 kilograms of nitrogen for a 100-day period. So I'll send this around so you don't have to jot all these numbers down. But I also have a handout that has all this explained. But so what it looks like is, what's quite interesting here is that the oysters might very well be a catalyst in this process. If 10% goes into growth, and 90% effect might be on denitrification. So then the question now is that how do you set this up in the pond, or even in the culture area? This year, Sia told me that we're planning to culture 2 million.
Instead of 1 million.
And we're going to start sooner. This was a very late start.
Yeah.
This was like in July. So this year.
Year 2.
Yeah, right. This is year 2, right. And the reason we did the denitrification in year 2 is because in year 1, we thought the impact was larger than we expected from the growth. So we expanded this. So now the question is, what do we do this year?
Okay.
And how do we structure the monitoring? I think that's really what we need to get down. If this is more significant or less significant than I've sort of, come up with in a very limited database, to talk with the SMAS team and find out what their thinking is from the results. And Brian House actually responded with saying, this sounds an interesting thought experiment, okay?
Well, I think that's a fair depiction of it. It's a
Yeah,
thought
thought
experiment.
Yeah, I don't,
Well, this is what you're saying happened last year.
yeah.
So is it consistent with the measurements of nitrogen in the estuary?
Well, as much as we can see, yes. I mean, we're talking about 0.3 acres in a 45-acre estuary. So the thing is that we did see an impact in better
Localized.
transparency, less nitrogen loading in the vicinity of the aquaculture. Okay. So, but if you look at, we're like taking a needle and sticking it in a actually sticking a haystack and trying to figure out, okay, how much of an impact? Well, it has an impact there, but if we went from 0.3 acres up to however many acres, I don't know, to deal with the whole issue, or to have a more significant impact, we'd see more. But this is just, overall, it's a small kind of a small intervention that could be enlarged, and then we could see if it could be more.
We have to admit that there are a number of assumptions here, and one is that you have an effect that is equidistant in all directions
Right,
from your area where you definitely have your rafts.
right.
Whereas the tide going back and forth, fecal pellets would be carried to some degree by the stream of water. So it's not likely that this is an actual depiction of where the deposition of the
Right,
pellets
well,
would be.
I don't know how far, but it was just from that graph that they'd shown about the probability, and just sort of, you're right, it could
Right.
be.
But the probability isn't the same in all directions, is
No,
what I'm saying.
exactly.
But if you could change, that's a good point. And the way around it is, if you can change it, because it doesn't really matter where it is on the estuary, right? It could be the shape of Santa Claus. It still removes that much nitrogen.
Right.
If you have the amount of pseudofeces per oyster, per kilogram of oyster, then you could do all the calculations on
Well,
that basis.
It's more the denitrification end of it. I think I don't know if we're going to be able to measure the pseudofeces that well, but they do have some estimates of it. But it is, I just think that, in just looking at the numbers, because in the report, they just reported what they found. They didn't say what the significance could be.
And I don't think they're ready to do that.
Right, exactly.
I think they want more data,
Yeah.
and you're posing some
Just
tantalizing ideas
Think
that,
about-
might.
How to think about this summer is really what this was all
Right.
about. It wasn't
How to
anything
think
more
about
than
this
that. And just saying, okay, well, we got these numbers. But you look at those numbers, 165.5 milligrams per square meter per day.
Yeah.
Well, that seems like, what is that?
Yes.
But then when you multiply it out over 100 days, and if it is widespread, then it's a big deal. But if it is, but that could be, I was just trying to work from what we have today to try to think about how to proceed into the future to understand.
Good.
And so, again, the basic assumptions are here. I've got a much more detailed sheet here that explains it. But then this thing from the Virginia Institute of Marine Science, which was, almost the same number, but that's not really relevant. It just means that we could be somewhere in the vicinity of, this could be somewhere in the vicinity of what's really going on. So I think that what I would like to do, what I would recommend, because this is not an agenda item really, this is just a report, is that maybe at the next meeting, we may even invite Brian House to come or talk with those folks and just have a session to discuss what their plan is for this coming season and how they'd like to look at this, because I think that they're feeling that they've gotten, some good data that hasn't been, and there's not that much out there, so that's beginning to at least get a foothold or a toehold or something maybe. So that's really what I would like to suggest based on this, just to have a discussion and see what he thinks, and if he says, no, well, and how to structure it so that we get the best outcome. Because we have some pretty good data on a lot of things. I mean, huge amount of data on the report. But the thing is that, as I say, we're interested in nitrogen attenuation.
Yes.
That's primarily, as well as making
Tools.
sure we're not doing any damage, but I think that any further impact, adverse impacts, and both years they've seen there's been no additional significant change.
I
Steve?
think those are all good points, and I agree with it, sensible. But I would think you would want to have at least one working group meeting to discuss it before you brought it before the
Committee.
water quality.
And I'm sure Sia, if she were here, she would say the same thing.
Yeah, that's fine.
So that's a good idea, okay.
Okay.
If it either, so it probably should be within the next 2 weeks. that
Yeah, right,
We have some
definitely.
sort of.
Right, we'll let the
working group.
dust, maybe after the dust settles after Memorial Holiday, and
Good
then
enough.
start looking at that.
Okay,
And I'll try and coordinate, or maybe, I'll coordinate with Sia, and then maybe she can coordinate it. But I think that, that this is just interesting. We always assumed, based on data in the literature, that there would be some denitrification that would be a complement to what goes into growth. But actually, 2 years ago, Brian Howe said that he just said at the CONCOM meeting that it could be up to as much as 10 times higher than what goes into growth from an ecological theoretical thing. And it just so happens that this particular calculation, which I think is conservative, but it didn't include beyond that 54 meter range out to the 103. I just left that
Right.
blank.
But I'll give you a heads up on how I would attack anything that comes out of this. Is if it's what was planned was that the studies the last 2 years would be enough to just barely see statistical significance, not assuming this good effect, right? Just assuming the weight of the oysters.
Mm. Yeah.
The back of the envelope calculation was such that you just barely see a change in the nitrogen concentration, which made sense, and enough to see if there's an effect, but not so much to blow the budget.
Yeah.
If in fact it's 10 times better than that, there should have been a huge effect last year.
There was. For this little tiny space, 0.3 acres, that's
Yeah,
like...
but I think those first assumptions were based on mixing within the whole estuary.
and that didn't occur.
Yeah, we covered about 1/1500th of the estuary of the oysters.
And you also have to realize that, first of all, we have a statutory limit as to how much of the estuary we can cover.
Yes.
And you will also have a neighborhood opinion about putting more rafts out. That's begun to surface, that some people think, well, this is an experiment, but we're not expecting to see this here forever.
Well, we'll
And
see.
it's the neighborhood and the town are going to have to decide. If this is
I-
effective enough, the town may say this is part of our treatment. But
Yeah. Just one more thing. In terms
Not
of this
decided.
year's plan, which
Year
is
3.
in the move already, in terms of numbers of oysters,
yes,
the 2 million could be put in probably from our discussions up until now in about 0.5 acres instead of 0.3.
and it depends on how close together you put those
Well, if it
lines.
was, yeah, similar density, I think, but we could, that's all discussed, we can discuss all of
Okay.
that as well. But it was only 0.5 of the 2 that we've been authorized.
Right.
At possibly the minimum. We could probably spread them out more, but yeah, so anyway, but I think it's something worth discussing further, just to find out which way
Okay.
we should go with this year's program. And one other point I'd just like to make is that I talked to Lisa Kellogg, who did the work in the Chesapeake with the reefs, and she said that oftentimes they don't see very much associated denitrification with aquaculture. Okay,
In a reef,
no, with aquaculture, not
with
the reef,
aquaculture,
yeah.
not the
And-
reef.
But she said when they're floating bags, they're usually in areas where there's a lot of current. So it kind of really disperses it a lot
I
more.
see.
Whereas in our case, it's something clearly
Yes.
there. There's a southerly movement for sure.
Right.
But it might be that because we have these situations in these estuaries, it may be more impact. I don't know if it'll be this much. I don't know what
Yeah.
it'll be, but anyway, I just wanted to
It's a good
mention
point.
that too.
Well, thank you. Thank you, Ron. Okay, so the to-do out of this is the working group needs to meet
Right.
and flesh out what the plan for year 3 will be.
Great.
Okay, and my report has to do with the hydrology for Acapesket. The drilling was done, there are two drilling sessions, and the first drilling session was this week, and it's concluded. We had 2 deep wells put in down to more or less 80 feet. Found the saltwater freshwater interface at a different point, which is useful information. We're trying to build a regional picture for this northern part of the Acapesket Peninsula so that we really understand the hydrology. And some additional monitoring wells, water table wells, were also installed. So now each one of those wells has to be what they call surveyed in, so we know the exact elevation of the wells, and then they will make a precise measurement of the elevation of the groundwater, and then that will help tell us what the direction is. No water quality samples yet.
Oh, no water quality samples.
No,
I was just going to ask, given McGrath's talk last time,
Yes.
have you hit a plume yet?
No, I don't know.
I don't know.
No
He said
water, no
you're
water
unlikely
quality
to hit a
samples
plume with a
taken.
well, but he
So,
said,
Yeah.
Do we have a map somewhere where we can see where the points are?
There was one. At the time
yeah,
was
there was one.
Yes.
The old one, oh.
Okay, let me see if this is,
We
here's
were
Great
shown where
Pond.
they were going to be.
Yes,
Oh,
right,
okay, I was away
exactly.
for a couple meetings.
So, 2 are on Shorewood, okay? One is very near where the original, Wynn, maybe you want to come a little
Yeah,
closer. The original wells were drilled down in this area.
Right.
So, and you remember there was one at the center of the peninsula and then one on the corner of the road. So this one is closer to the pond. All right, one there, one up here. So we're at the head of the peninsula, and where we think we'll see more of the regional groundwater. Then this is John Parker Road. There's a water table well here, and then there's a water table well here behind a gas station, a property that a private owner allowed us to put in. So to create a more definition of the groundwater contours in this area, that was the goal.
Okay, so nothing, but we're, I disappear just for a second.
Yes, sure.
I was just thinking, well, anyway, I was just thinking, so that, at least this one is really downstream of.
Yes,
bunch of
absolutely.
houses.
Yep.
Okay.
And this is an effort now, quote, in downstream sense.
To
What
see what the flow is coming
here
down.
versus here,
Yeah.
right? Do we have just localized groundwater in this area? And this is the more regional area, or
this
not?
could be diluting too as it comes down.
Yeah,
You know.
then we get into water quality issues.
Yeah.
Anyway,
Okay,
fortunately, no hitch in any of the construction. So
Okay.
that's very good. Okay. Now, let's discuss meeting times for June.
I suppose that we switch to the summer schedule. You may be able to figure out why.
There's a few people on the.
I see.
But even if you don't have a boat, it's very nice weather out.
Okay, the summer schedule meeting going to an evening meeting.
As we used to do.
Okay.
Eric had been, so I don't want to put words in his mouth, but I think I gathered that he expected to do that at some point.
Yes,
And it was really a question of when the transition would occur.
correct.
And I'm merely lobbying for it to be earlier rather than later.
I see. So you're, okay, to start in June. Ron, what's your opinion?
Well, I have a similar opinion, but I need slightly warmer water to appreciate that situation. So
I
it could
see.
be a little bit, I mean, it could be starting with, say, the second meeting in June.
In June,
I
which would be
say.
the 18th.
Yeah, I
All
would say
right.
something like that. But,
When the question under discussion is the timing of the meetings in June. We
Okay.
normally would meet on the first and third Thursdays, so it'd be the 4th and the 18th. Do you have any preference for the 3:30 in the afternoon or going back to 7, which is what we did
7,
last
right.
time?
I mean, I don't want to be a pig,
Okay,
but I want to mention it and hope
Yes.
that other people.
I thought we mentioned this at the time of the change.
we
actually.
did, but we
Yeah,
didn't,
yeah.
we did not agree on when that change should be. And so obviously, we're missing 3 members, and but this will be discussed. So Wynn, just getting your sense of,
I have no problem one way or the other with
Okay.
Thursday, the 4th.
okay,
I
or the 18th.
Yeah, I guess I don't have much of a problem, well, yeah. I don't know what to say about the 18th. My brother-in-law will be here from Germany, and probably my son and his wife and so forth will be coming on the 18th.
I see.
And I don't know, they may have to be picked up, so I don't know, I
You
have
don't,
no idea.
okay, got it. All right. Well, let's just table that and
Okay.
but we'll
Which is-
discuss it.
What is the day of the next
The
meeting?
day is the 4th,
The 4th?
Thursday
Okay.
the 4th, and Thursday the 18th.
Should we just assume 3:30 unless we hear otherwise?
I think so, yeah. Let's say that. 3:30 unless we decide differently.
Yeah.
What?
And then the subsequent one would be
And then in
the
July,
18th. It would be, then there would be one on the 18th of June.
So
That's
we're
right.
saying for June, we'd keep to this schedule, is that it,
this is not definitive.
Oh, okay.
Eric's going to decide.
Right.
But Steve wanted to raise the issue. It gets time to think about moving
Right.
to later dates,
or?
later times.
Well, whenever we do that, we would need to have, again, to be sure this time that we have several broadcasts.
Yes,
Some way that
that's
with
right.
Big red letters.
Okay, fair enough. She's,
Yeah.
we're on to that. Okay, and then last item is to vote the minutes of the last meeting, which was the meeting of April 30th.
I noticed no problem.
I just have a comment about the minutes. We actually have two records of what we do here. One is the minutes, which is a
Right.
very condensed
Right.
view, and the other is the video
Yes.
thing, okay? And something struck me last time that John had mentioned, and he's not here, so it's a little bit, since we're talking about the minutes of that period, it won't come up again. He'd mentioned that we were talking with Mike McGrath was talking about, nitrogen and carbon and everything in the ground for water. And John had mentioned that in terms of carbon, that 50% of what we ingest, we breathe away, and 50% goes into body needs. Okay, so that struck me as odd, and that's 100% of of it basically doesn't go out through our waste stream. Okay, so 50% he said was.
You're quoting Mike McGrath?
No, I'm quoting John
You're quoting
Waterbury.
John?
Yeah.
Well, okay,
Yeah.
that doesn't, we would need to double check that.
I
Yeah.
didn't
But anyway,
understand that quite
I
the
checked-
same way, but.
No, I checked the video to be sure.
Okay,
But then I went and I looked at the literature, to try to figure out what it is. And it turns out that about 88% of what we eat, we breathe away. They use the term expire, which is.
yes, that's correct.
Yeah, so it leaves about 7 kilograms, because this had to do with denitrification and groundwater and all this stuff. And so it leaves 7 kilograms of carbon that actually comes out through our waste stream, okay, from us, compared to 4.5 kilograms of nitrogen. And this is per year in terms of what comes out, okay? So it's 7 kilograms carbon and 4.5 kilograms of nitrogen through urine and feces.
And that differs a good deal depending on the diet.
Well, this was based on a report. Yeah, it depends on diet, but it was a report that was called the Human Carbon Budget, an estimate of the spatial distribution of metabolic carbon consumption and release in the United States. Okay,
Yeah,
so it's
in
obviously
US, yeah.
more general, but they said 67 kilograms of carbon is what we eat, and then it goes off. But about 10% ends up actually leaving into wastewater. And so that's about a 3-to-2 ratio. And the question was, is the carbon to nitrogen ratio good for denitrification in the groundwater? This was the thing. So it was 3-to-2. Well, then I went to a book called The Removal of Nitrogen Compounds from Wastewater, an Elsevier publication, and they said the ideal ratio is 2 to 3 carbon to nitrogen. So it's the opposite. So it seems like in the human waste stream, there should be 3 to 2 is more carbon than would optimally be needed, according to the 2 to 3. So the only question is that there are a lot of other factors. There's alkalinity, dissolved oxygen, pH, other elements, a lot of things that affect it. But it may not be that it's so carbon limited. It may be other factors that affect it that we don't know, but that was the
Could
one
I
thing.
ask,
Yeah.
why are we discussing this when I thought we were
Well,
going to be
because
approving the minutes?
I'm talking about the record of the record that's there.
Of the meeting?
Yeah, and
Okay.
so I'm just trying to say that, to try and put that in a slightly different light because of what, I mean, I think he was just trying to inform the public of this thing, but there is this other dimension really that takes place, and so.
Okay. But in terms of the
Yeah.
minutes,
That doesn't have anything to do with the minutes.
yes,
We have the minutes, right.
You
Now
were-
we-
all right,
If somebody
yeah.
says something you don't agree with, it's just a question of whether they said it or not.
yeah,
Well, it's in the record, okay, it's in the video record.
Okay.
So I just wanted to be sure
and
that that was.
you've
yeah,
now added
yeah,
your, because
right.
you were not at that meeting.
I
But
was
do-
at the
Do I
meeting.
have a motion to?
No, I was at the meeting,
You were? Yeah.
yeah.
I'm
Sure.
talking, minutes of April 30th, present, Eric,
Oh.
Matt, Wynn, John, and Steve. You were not present.
April 30th. Was this, wait, are there two sets of minutes here or just this one?
Well, these were the
It's the
minutes.
meeting
that-
No,
or
we didn't have a
spoke.
meeting on May.
No, I was there.
You were there, okay, well, these minutes are,
And that is a legitimate.
okay, yes, okay, so we're correct? Okay,
If Mike McGrath was there, I was there.
you were there. Fair enough, okay, so the minutes stand corrected. Do I have a motion as corrected?
So moved.
Second.
All right, all those in favor?
Aye.
All right, and a motion to adjourn.
Motion to, okay.
Second.
Okay, I'll
Okay.
take it this time.
Thank
Okay.
you very much.
Motion, second, okay, great, thank you.